Hi, today we are going to discuss about referencing object. Python is an object-oriented language, a well-known fact about Python. Now, what special in Python is, every entity that you see in Python will be treated as an object itself. For instance, variable is an object in Python, function, class, etc. are going to be treated as an object in Python. It falls under a specific type or a class, but they are going to be considered as an object. Now, how do we understand the referencing of object in Python? We are going to declare a variable called a, and I'm going to assign a value for it as 10. Once this statement is expressed, and once you are going to give this statement for an execution into the Python interpreter, the Python interpreter is going to apply a two-stage factor. Stage 1 is going to be where the object is going to be created. What type of an object is going to be created by the Python interpreter is none other than an integer object. Why? Because the value that's been assigned to that variable is of type numeric, so that it's going to create an object of type integer. The next stage is where the value is going to be assigned to that object, and the value is 10. Post the value is getting stored in that particular object of type integer, we need to access the value of that object. So how do we go about accessing that object or a value in that object? Is by using the symbolic name called a. A is none other than a variable name, and you will use this variable name, which is a symbolic name, in order to access the object, and the object value is 10 and the object type is an integer. Now, we will get to know this understanding of how this type is assigned by using the built-in function called type. Python offers a built-in function called type. Using the type function, you can capture whether this variable or an object is of type integer or a numeric. It practically depends on the value that you are going to assign to it, so that the type function will return the type of that particular object. So let's see an example of it. The first thing that I'm going to do here is declare the same variable called a equals 10. So once the value 10 is assigned to this variable, and if you are going to give this expression to the Python interpreter, what's going to happen? That's what we saw on the slide. Two-stage factor is involved. In stage 1, it's going to create an object of type integer. Post the value 10 is going to be assigned to it, and the object is going to be referred via the symbolic name called a, and that's what we call as a variable name. A is a variable name, but technically speaking, it is none other than a symbolic name. Now, how do we go about getting this type of this particular object? Is this an object now? Yes, indeed. Python is going to treat this as an object. So let's see the type of this object. For that, we are going to use the function called type. Print type of a. By executing this, you can visualize that the type of this object is going to be an int. So what you can understand from here is, we have declared a variable, but the Python interpreter is treating it as an object of type integer. So this integer is actually of type class. So it can fall under a type or it can fall under a class. So int is none other than a class, and what you create for that int type is an object. So once you create an object, let's presume that this is going to be an object. What the Python interpreter is going to do? The Python interpreter is going to assign the value here, post declaring this object as of type int. It is an int type, and then I'm going to refer to this object by using this name, the variable name called a, or we call it as a symbolic name. So a is just a reference to that particular object. So whenever you want to access that variable, or access that particular object, you need to use this variable name. That's what I'm doing here. By accessing this variable a, you're able to capture the object in it, and you're forwarding that object to this function called type, and the type is eligible to find out what type is that object is all about. And we are getting to know that this is an int type, and you also have the declaration of that int is none other than a class itself. So like this we can see many more examples of it. So I'm going to take few more examples in order to understand how this type function can help us in getting the type of the object. Now looking at this variable called x is going to be of value true. So this time we have true as a value, and if I use that print type of x, you all can guess the output of this expression now. It's going to be a class of bool. Bool means it's a boolean. I'm sorry, it's going to be of variable x, so that you get to know that it is a boolean type. Similarly, we can find out a variable of a floating point expression, okay, and you can print that by using the type function to know what type is that variable is all about. It's a float. More interestingly, we can even define a function, a simple function called add, which takes a couple of parameters in it, and you just return that statement of x plus y. So we have declared a function. It's not just about the variable alone. Object referencing happens for every entity that takes place in Python. It could be a variable, it could be a function, or it could be a class. Now if you look at this function statement, I'm going to print the type of the add. Add is treated as a function name. It's again a symbolic name for referring the function object. Please be noted, so far it was defining a type of int, bool and float, but by now it's going to define an object of type function. So when I execute this, you can notice very clearly that the type of this particular symbolic name is none other than a function. So function is an type, and it creates an object for it, and naming that object as add, that's add. So in order to access that function, or in order to access that object, you will use this symbolic name. So by this way we can understand that all entities that we have in Python are going to be treated as an object. It could be an int or a bool or a float or even a function are treated practically as an object. Why not? Let's take one more example to understand this flow. I'm creating a class called employee, and I'm going to have some empty declarations of it. So I don't have any particular statements in this class. Now what we can do is we can quickly go ahead and say print type of employee. I wanted to know what type this employee class is all about. So it clearly says it's a class of type. Employee is a class of type. It's just a type. You can further create an object for it. So let's say emp equals employee. By this way, I want to know what type this variable emp is all about. Print of type of emp. Now if you notice here, it clearly states that emp is an object. Emp is an object of type employee. But class employee by itself is also an object of type called type. So you have primitive data types which are treated to be an object. Your functions are treated to be an object. Your class declarations are treated to be an object of type called type. And you create an object of employee. When you create an object of employee, then what happens? It again refers that emp is of type employee object. So you create an object and you assign a name for it called emp, and then this is of going to be type employee. Employee object is what we have created. So usually when we understand the concept of object orientedness, we treat class creation of object alone to be an object. But in Python, everything is considered as an object. So that's the conclusion of this video. We'll see the next topic in the next session. Thank you.